All right, let's take a look at 4.3a, some other common functions. Right now we've looked at linear functions, a line, and quadratic functions shaped like a parabola. We're going to look at some other common functions. I'm basically going to show you pictures of these guys. Here's the two we've looked at so far. This is the most basic expression of the linear function. It could be enhanced to be f of x equal 2x or 2/3 x or 2/3 x plus 7, but the basic vanilla form is f of x equal x. That's your linear function, a line. Here's f of x equal x squared. Here's your quadratic function. Its basic expression is a parabola. X squared, x to the third, x to the fourth. If we did x to the fifth, guess what? Any of your even functions, x squared, x fourth, x to the sixth would be even skinnier, but it would still be a parabola. x2, x4, x6, your even exponent functions are upward turning parabolas. X to the third, this S shape. S to the fifth, a skinnier S shape. X to the seventh, an even skinnier S shape. So your even functions will have basically a parabolic upward turning U. Your odd functions, x to the third, x to the fourth, x to the third, x to the fifth, x to the seventh would have this look right here. All right, something else. 1 over x. Here's the general look of this guy. 1 over x. 1 over x squared. Please notice, basically the same shape except they're both above the x-axis. Now I'm going to be putting all these basic functions on your quickly content, so you'll have these examples to hang on to, and I would suggest you have them handy. And by the way, 1 over x to the fourth, what do you think? It's going to be a skinnier expression of this. 1 over x to the sixth, same general shape. 1 over x, 1 over x cubed, same general shape as this. So odd and even expressions when the x is, notice, in the denominator of your fraction. All right, look at these guys. We're not familiar with a fractional exponent yet, but this is another way of saying the square root of x. So here's a picture of the square root of x. Notice there's nothing on this side because I can't have any negatives over here, negative x's. I can't take the square root of a negative number. That's why there's nothing on this side of the y-axis. So the square root of x looks like this. The cube root of x looks like this. Notice stuff on both sides of the y-axis because I can have a cube root of a negative number. It's just another negative number. So square root, cube root. And here's one that you're probably familiar with, the absolute value. Absolute value of x looks like this. If I was to multiply it by, say, 7, it would get skinnier. If I was to multiply it by 2/3, it would get broader, but it's still the same general shape, an upward turning V. Now all these graphs are going to be the answers to questions on your Hawk's problem. The Hawk's problem will say, what is the general shape? In other words, don't be real specific, don't find points, but in general, what does this thing look like? So if it's basically an x squared function, an x cubed function, an x fourth function, an x to the fifth, and x to the sixth, you basically got the look of it. 1 over x, 1 over x to the third, 1 over x to the fifth, 1 over x squared, 1 over x to the fourth, 1 over x to the sixth, same general look. Square root of x, cube root of x, absolute value. So if you have these, basically these 9 functions identified, that's basically all the functions that we're going to be dealing with in the next couple of sections. So hang on to these 2 pages. Run it off, hang on to these 2 pages. Now the only thing you have to be cognizant of when you're asked to identify the basic shape is this. Is the number in front of this guy positive, as it is in each of these cases, or what if it's negative? Well, some of you know what a negative in front of this function will do to it. Put a negative in front of this guy, and it goes down. Instead of going up, it goes down. It basically flips over the x-axis. Same with this guy. F of x equal negative x squared goes down. Again, it flips over the x-axis. F of x equal negative x to the third. It flips over the x-axis. So this part that goes up is going to come down. This part that goes down is going to go up. Just flips over the x-axis. F of x equal negative x to the fourth. Hey, just a skinnier parabola except going downhill. This guy, let's do f of x equal negative 1 over x. This flips, everything flips over the x-axis. So that becomes this becomes that. So it basically flips over the x-axis. Same with this guy. Flips over the x-axis. Okay, this guy, not a problem. If I had f of x is negative square root of x, instead of going like that, it's going to go like that. This guy is going to go like this if there's a negative. And this guy, of course, will go like that if there's a negative. So make sure you're staying aware of the fact that is it a positive or negative coefficient, number in front of my function. If it's positive, then it's going to look just like these guys. If it's negative, they're going to flip over the x-axis. Just do a mirror image of them over the x-axis. All right, with that in mind, let's look at a couple of problems. Now, I'm going to keep this handy because I'm going to be referring to it. All right, consider the following function. G of x equal, right away, look here, negative 4/5 x to the third. All right, notice what it asks for. The general shape of the graph. In other words, I don't have to worry about this 4/5. Just forget about it. What I need to think about is what does g of x equal negative x to the third look like? So I'm going to find x to the third. Oh yeah, it's negative. So it is going to go down here and up here. And so I will choose to identify this graph as the general shape of my function. Now it says find 2 points on the graph of this function. Here's where I do have to be specific. G of x is negative 4/5 x to the third. And notice what it says. Pick some points that fit within the negative 10 to positive 10 grid. So in other words, I don't want an x, I don't want a y that's larger than 10 and no smaller than negative 10. So let's pick an x and let's find a y. Hey, a good one might be, and remember, g of x is the same as y equals, right? other than the origin. If I'm tempted to pick 0 and make this 0, that would be really nice, but it says, yeah, don't pick that one. So let's pick 1. Let's let x be 1. And I know that y is going to be -4/5 times 1 to the 3rd power. 1 to the 3rd power is just 1. -4/5 times 1 is -4/5. And it says make each coordinate an integer, yeah, or a simplified fraction, yeah, -4/5. All right, you want to try 2? Let's see what happens if I do 2. See if that's going to be too big. 2 cubed, that's 2 times 2 times 2 is 8. -4/5 times 8 over 1, 4 times 8, -32/5. And put that in your calculator. That's not bigger than -10 or smaller than -10. So these are both good points I could choose for the satisfaction of step 2. All right, let's try another one. Consider the following function. Q of x equals 7 times, the absolute value of x. Identify the general shape. Is my coefficient positive or negative? It's positive. So it's going to have exactly, since it's positive, exactly the shape of this guy, except a little bit skinnier. And it's the choice that Hawks is going to give you is this one right here. So this is the general shape of my function q of x. So I'm going to pick something that looks like that. That's all I have to do. The general shape. Don't have to be specific. Now find 2 points on the graph of this particular function. And other than the origin, can't choose 0, that fit within the -10 to +10 grid. So here we go. My q of x is 7 times the absolute value of whatever x is. Remember another way to say this? Y is 7 times the absolute value of x. So I'm going to pick me some x's and find some y's. A good one, I can't pick 0, right? Because that would make the origin. So I'm going to pick 1. Absolute value of 1 is 1. 7 times 1 is 7. Now if I pick 2, absolute value of 2 is 2. 7 times 2 is 14. That's going to be too big. So let's pick -1. Absolute value of -1 is 1. 1 times 7 is 7 also. So I got me a couple of points for this particular function. Remember, at any time you want to, anytime it's convenient for you, you can re-express a function notation as y equals. This is especially handy when you're looking to find an x, y, a point on this particular graph. All right, let's try another one. What the heck? All right, take a look at this. This is called a piecewise function. I hate to say it this way, but this is basically a schizophrenic function. It hasn't quite decided what it wants to do when it grows up. In fact, it is defined in 2 different ways. On one particular occasion, it's defined this way. On another particular occasion, it's defined this way. So it has 2 different ways to think about this function. All right, but get this straight. These qualifiers on the right tell you exactly when the function looks like this and when the function looks like that. For instance, if the x you pick is less than or equal to -2, something like -2, -3, -4, -5, -20, -20,000, then this is how you find the y, right here. If the x happens to be greater than -2, like -1.7, -1, 0, 2, 5, 27, 38, greater than -2, then this is the way you find the y on your particular function. So based on what your x is, go immediately to the right side to find out, hey, is it defined by the top function or the bottom function? Let's look at this. Identify the general shape and direction of the graph of this function on the interval from -infinity to -2, look at there, including -2. That's this guy right here. This is from -infinity all the way up to and including -2. So I want the general shape for this function right here. First thing I got to do is identify which of my graphs this is. Hey, look at there. Forget about the -12. Forget about the -6 for a second. This is just equal to x. This is your linear function. This is a line. So I'm tempted to go, hey, it's just a line like this, until I realize, wait a second, there's a negative in front of it. So it is a downward facing line. So there's the general shape and direction of the graph when it satisfies these conditions right here. All right, step 2. What's the general shape when it satisfies those conditions? From -2, not including -2, but from -2 all the way up to infinity. So in other words, my second expression. All right, look at this guy. This is my x squared function. This is my quadratic function. And notice the coefficient, positive. Doesn't matter that it's a fraction, it's positive, so it is an upward turning parabola. All right, identify the correct graph of this piecewise defined function. All right, here's what we got. Obviously, the turning point is at -2, right here at -2. It stops being one function and starts being the other at -2. From -infinity all the way to -2, it's this guy. So all the way from -infinity to -2, it looks like this. Then all of a sudden, from -2 on, it starts looking like that. All right, first thing I want to do is find out which of the functions has the end point of -2. And it's this one right here, right? Because you're going to have an opportunity to either have a closed circle with this one or a closed circle with that one. Closed circle meaning including the point -2. Well, I don't want a closed circle with this one. I want an open circle with this one, because -2 is not part of it. At -2 for this function, I want a closed circle. All right, so it's going to go, remember, it's going to look like this from -infinity all the way to 2, and it includes 2, so this is going to be part of this graph. And then from this point on, it's going to be a parabola. But remember, I got to start at 2 with an open circle. So it's going to be a parabola all the way to 2, but at 2 it's going to have an open circle. So if I check -2, I notice that -2 is part of this graph, not part of that graph. That's the look of a piecewise function. It's broken in part. It's schizophrenic. It's a line for a while, then it turns into a parabola. The one thing you have to be aware of is which function, the line or the parabola in this case, with which function does the turning point, is the turning point included? With the line or with the parabola? Hey, the equal to sign right there says it's with the line. So there's a picture of my piecewise function. Alrighty, let's do one more. Another piecewise function. This is what the function looks like if x is less than or equal to a -4. Here's what the function looks like if x is greater than -4. All right, let's see what it asks us about this particular piecewise function. Evaluate this function at x equals -3. All right, first thing I have to decide, which of these functions do I substitute -3 into? Is -3 part of this function, or is it part of that function? And one thing you might want to do is think about a number line. -4 is the break. Here's the first part, less than or equal to a -4. And here's the second part, greater than -4. -4 is my breaking point. So where is -3 on this graph? Oh yeah, it's right there. So -3 is part of this particular function. So I'm going to find f of -3 by using this function right here. Since -3 is greater than -4, it's to the right of -4. So 3 times my x, which is -3, minus 6. -9 minus 6, that equals -15. So f of -3 is -15. All right, notice what I had to do first. I had to decide which piece of my piecewise function addresses this particular x. All right, let's try the next one. Evaluate the function at x equals -4. All right, -4 is the breaking point, right? So which part, the first or the second function, or the first or the second part of the piecewise function, which part is defined at x equals -4? There's my equal to sign right there. So this guy is defined by my first part of the function. How do I know? Because of that equal sign right there. So f of -4, I'm going to use the top function. -1/2 times whatever I have, whatever my x is, plus 6. Now I got a negative times a negative, so it's going to be a positive. 1/2 of 4 is 2, plus 6, 8. So f of -4 turns out to be 8. Again, I can't evaluate the function at x equal -4 until I decide which of these two functions, which of these two pieces of the function is used to evaluate x equal -4. All right, one more. Evaluate this function at x equals -8. All right, obviously -8 is over here. That means it's part of the first function. So I'm going to use the first function to evaluate x equal -8. f of -8 is -1/2 times -8 plus 6. Again, a negative times a negative is a positive. 1/2 of 8 is 4, positive 4 plus 6. f of -8 equals 10. All right, I will get this information to you ASAP. Good luck with the other common functions.